Is the video rolling? Yeah? So, I don't know if you know, but this gets replaced by a video. So, okay? I've got a 3-year-old son. Well, he's going to be 3 in July. So I get to show him that, and he'll think I'm scaring the dinosaurs. So that's pretty cool. That's the only relation that dinosaurs have to this at all. Now, you'll think that's weird, but hopefully when that's played back on video, you'll go, oh, that's what he was doing. Yeah, so this talk's on testing ginormous JavaScript applications. It's related to some of the stuff that Justin spoke about, and also there's been discussion on components, so that kind of feeds into it too. My name's Phil Leggetter. I work for a company called Caplin Systems. We're based in London, but myself and Andy Berry, he's on the stand upstairs, we live near Stirling, so we get to work from home and work for Caplin. We're part of this team that are open sourcing this product called Blade Runner.js. The point in that is that the Caplin systems help their customers build large front-end, well, large trading applications, trading platforms, so back-end to front-end. And part of that is a large HTML5-based single-page application. And we need some tooling to help us build these things in consistent ways, in high-quality ways. And this tooling helps us do that sort of thing. So I'm not talking about Blade Runner.js here. I'm just talking about the practices that we follow when we develop our apps. So Blade Runner.js is open source, so come and chat to us upstairs, please. So what I'm hoping is that we can talk about what we do as part of the open sourcing process, and then go next door and discuss, what we do and why we do it. So not dance or squabble like dinosaurs, but actually, discuss and say, this is how we do it. How do you guys achieve similar things? So the talk from Justin was really valuable in terms of feeding that into what we do. So please do come and talk about this afterwards. So this is more about a story about how we built our Caplin Trader 2 based application and then Caplin Trader 3. And hopefully you can apply what we do to some situations that you're in. So this is Caplin Trader 2. It's a large single page application. Everything, a lot of front-end functionality, offers complex functionality, complex interactions as well. So in terms of the user being able to do lots of stuff with this UI, in terms of interacting with the UI, graphs, executing trades, and so on. But also there's a lot of interaction going on in terms of the components within that technology. So front-end components interacting with each other, and also front-end components interacting with lots of different back-end services. This is a kind of single-page application, a desktop replacement application that you would leave open all day, a bit like Gmail. Gmail's a really good comparison. But I think the things that I'm talking about will be applicable to other highly interactive single-page applications. So Caplin Trader 2 Codebase, I pulled it down just the other day to have a look at the content. There's 1,500 JavaScript files in there, 250,000 lines of JavaScript code, all that runs in the browser. Lots of test code, templates, CSS images, and so on. So no matter how good a developer you are, the bigger an application, the more functionality you add to an application, the more larger code base you're going to have. So you're going to need to deal with that. Now, our dev practices, even back in 2009, actually, were that we had multiple teams contributing to the same code base. We used Scrum. We had 2-week iterations. Every time we checked in, it kicked off a build process, so we had continuous integration. And at the end of that build process, we would have an asset that we could potentially ship. We had a build status screen, which is really trendy back in 2009. When it broke, you obviously wore a silly hat, or I think we had a rubber chicken that you had to have, and Andy's actually got that in his office now. But the point is that it's a focus on building quality software in an iterative way. Part of that is obviously testing. A massive part of it is testing. So we had requirements. Back then it was i6 plus Firefox 3.5. So this is actually taken 2010, I think. Chrome. And we did our testing at more or less 2 levels. Class unit tests, we do object-oriented JavaScript. We test at our class level. And we test at an acceptance test level. So a level that makes sure that the business requirements that we have are met by our application. So we're testing features that they actually work. This was our testing triangle. It's weird that there's so much crossover. So we had this fat level of unit tests, some of these acceptance tests, so end-to-end tests. I think there's a bit of crossover in how people refer to this. We call them acceptance tests, which meant that the full application was running and back-end services were running. And to power that, we use Selenium. Anyone use Selenium? Quite a few people. Cool. Okay. So, and we also had a lot of user extensions, Selenium user extensions that we needed to abstract away from just writing code, which was, selecting elements. We don't want to just use the custom locators. We want our locators to be kind of business focused, so that when we write our code, we're thinking about what it is we're trying to really achieve. And we even had this text abstraction, which you can't really see particularly well, but it's just a text file, and the idea of it there that business analysts could come along, write these specifications, and they could run against the actual app. And all this took place on a VMware. We had VMware infrastructure VM infrastructure to deal with our continuous integration. So this is a process we used to follow. I've given a hint there. We used to follow. So we used to have to pair up our VMs. So we had a front-end VM which would have browser assets on it. So i6, Chrome, Firefox. We had a back-end service which had all our back-end services that were required for this application. So before we kicked off this test, we had to pair those up. And the reason we had to pair that up is because sometimes the back-end services had to behave in certain ways, edge cases, services not running. So those were specifically set up like this. So once we paired up these VMs, we reset the state of the back-end VM to be in a flat state. We would then launch the browser, the full application. We would then execute our tests, probably interacting with our back-end. We would store the state. We would then reset the back-end services again, because we obviously don't want any state on the back-end transferring between tests. And then we would need to, so we actually restarted the browser. We killed the browser process after we'd recorded the results and restarted it again. You could potentially refresh. And then we can execute the next set of tests. So these are the test results. Oh no, sorry, am I jumping ahead? Okay, execute the test, yeah. So these are the test results. I'm not going to talk about unit tests. The focus here is really acceptance testing. So we had 500 acceptance tests, and we had 50 pairs of VMs, so that's 100 VMs. So the reason for that is so that we could run our tests in parallel. So we could run our IE6 tests against the backend VM, our IE7, our IE8, our Firefox, and so on. So that helped us, really get through these tests as fast as possible. The problem is, these tests still took 8 hours to run on this set of this infrastructure. Not only that, but if you think about that, and we've got multiple check-ins, you can imagine the build queue that's building up. So we couldn't do that. We could only run that full suite of tests at night. So we had a smoke suite of tests. I think that was referred to in one of the pyramid diagrams earlier. So that just tested the basic functionality that we required in our application. The problem with that, even then, is that our tests were highly unreliable. So we could run the same set of tests against the same check-in and get different results. So obviously we were doing something wrong. You can't test in that way. It's too long and it's too unreliable. So we needed to fix things. I hope this one's not too bad. So there was this email sent around the other day. Source Labs, I'm not slagging them off. This is Salesforce are saying that they can run 100,000 Selenium tests on the Source Labs infrastructure. Now, I don't doubt that you can run that many tests on a massive infrastructure. My question is, should you? So our belief is you shouldn't, because you end up with results like we had, unreliable and slow. So I want to explain why it's wrong. First thing is you need to restart the browser. So if we're testing Gmail and we're testing this chat functionality down here, and we kind of kick our test off, so the browser needs to load. So we refresh or we restart the browser, and we go, oh, I've gone too far, sorry. Here we go. Come on, video. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds. 10 dinosaurs that took. So for each test, we need to wait at least 10 seconds before we can actually start executing that testing. So that's 500 tests at 10 seconds. That's 83 minutes, according to my maths earlier. And then if you do that against i6, i7, ie8, and so on, you get up to 7 hours of testing. You can see how we got to that 8-hour figure. The next thing is backend services. When you're running the full application, in order for it to probably work, you need all your backend services running. Each of these backend services will have their own runtime, their own configuration. Restarting them will take a long time, probably. Even if it's a few seconds, it eats into that 10 seconds we're already waiting. Not only that, but it's software. Software sometimes falls over. We used to restart these services, and sometimes one of them just wouldn't come up for whatever reason. We could spend a lot of time messing with our development environment, our testing environment. We didn't really want to. The problem is you would execute your tests, and you'd end up with a test that failed, not because there was a functional problem in terms of the application, but because the environment that you were testing in was broken. So we're testing the test environment, we're not testing our features. We want to be testing our features that we're building. This is another one. So from our experience, you can't trust the DOM. You don't want to be touching the DOM. I said that we would run the same set of tests, and we'd get different results. We couldn't really track down what it was. A locator would just say that element isn't present this time. So you'd get a failing test, and then you'd run it again, and there was a timing issue, and it passed the next time. The next thing is that there's different arguments for this, but when you're writing functionality, you can change the CSS, you can change the HTML structure, but you don't change that functionality. You're just changing what the UI looks like. Do you really want to be affected not being able to change that UI and then having to go into your functional tests and change how your tests are written because you've made a UI change? So we didn't want that to happen. So we went, right, we're not doing that anymore. We're not going to use Selenium. We don't want to be using these selectors. So we treat the DOM in the same way that we treat I/O. We don't want to be crossing that boundary between runtimes. So we needed to start from scratch again. We needed to kind of readdress things, and this is in 2011. So there's three things we want to fix. We want to fix speed and reliability of most of these things. So the application running and the relaunch. So let's look at this. This is an amazing Google draw diagram that I've created, where we've got our application and the DOM running in the browser, and the network and backend services. So we don't want to run the full application, so what do? Components. So we split up our application by feature, more or less. So we do have reusable components across feature, but also we have this idea of this feature level thing called a blade. But again, they could still be components or modules or whatever you want to call them in your solution. So we've got our compose feature, we've got our list of emails, we've got labels, we've got our search feature. So now we've split up our app into these separate lots of features. Not only that, but we can take our assets, which are generally stuck under an assets folder and then the type, and we can bring them together and we go, right, for each feature, we put everything associated with that together. So we have high cohesion, we've got our images, CSS, JavaScript, and even our tests under that one folder. So we know where the assets are associated with that feature. So if we look at Caplin Trader 2, or this is actually Caplin Trader 3, I think a slightly different version. We've got this thing called the FX tile. Now what we can do, because our assets are on disk together, we can write some tooling that understands how to serve that on its own. So we can run that feature in isolation. So here we've got our FX tile running entirely in isolation. So we've got much faster reload times if we want them. And also it's naturally decoupled from it can't rely on any other feature that's running within the browser because they're just not there. So we're getting nice decoupling there. Another kind of aside, it's not, so we did used to go through running some acceptance tests at that level, so we got a bit of speed improvement. But one of the good things is that we can actually only run the services that are related to that feature. So if we don't have to have all these unrelated backend services running, you can just run the authentication service for the login and the real-time service for the latest news and so on. So what about backend services? So this is what we wanted to do. We actually come from generally there's quite a lot of Java developers in our company, and we come from kind of an enterprise background. And when it comes to JavaScript and enterprise, there's a little bit of a clash, but I really think that these things are coming to convergence, and we're taking the best from both worlds. And this example specifically works for us. So we've taken a service layer, which is a commonly used design pattern. And the point in that is it provides access to functionality that generally accesses back-end services. It doesn't have to, but an obvious way of thinking about it is something that accesses back-end services. Anything that hits a web API, and like a real-time service that does I/O, maybe into feature communication. So with testing in mind, what this service layer allows us to do is when a feature goes, give me the real-time service, we can go, right, you want a real-time service, we'll just give you this other object that happens to implement the right contract that helps us with testing. So I'll go into that in a little bit more detail with a really simple example. This is what we use. We use this service registry. That's just available everywhere. In this example, I'm creating a Firebase chat service. I'm registering it with the service registry, giving it a simple ID of a unique identifier of chat.service, and registering that instance. So that can be done at bootstrap time in different scenarios. And then here I can, within my feature, when I'm actually executing my feature logic, I can get the instance just do get service chat.service. So this is an example of a dynamic service locator. But you can use other examples like that. And the point there is, how simple is that? That's a lookup on a string. This is not an enterprise pattern. It's just a lookup on a string. It's really simple. We don't have to make these things too complex. So the great thing here is that because we've got this service registry, at different runtime scenarios, we can inject different implementations of that service. So in this workbench scenario, this top left UI is actually pretending to be the real-time service. It's registered itself with this service registry saying, I am the real-time service. So when our FX tile registered says to the service registry, get me this real-time service, it doesn't know, but it's actually getting a reference to this. So this lets us auto-generate data and push it through into the UI. It's just interacting with this contract, this interface. So we're getting lots of value there. The obvious value is in testing. So that can be like a manual testing scenario, the previous one. This one's real automated tests. So we can take these fake implementations that we've maybe used in our Workbench scenario, we can inject them into the service registry and use them to get to check that our business logic behaves in a certain way, and we can make assertions against what this business logic does. We can add a mock service using some sort of mocking library and add that to the service registry, manipulate our business logic, get it to do something, and assert the interactions that it's had with this service layer. So this is the wrapper, an example of the wrapper stuff that Justin spoke about earlier. So instead of having any I/O at all, we now have the potential of making all your services only run in JavaScript. So everything's just running in the browser. And at runtime, real runtime, we can make sure that the real implementations are injected. So we get lots of value from that too. So the final thing is don't touch that DOM. Our solution here, so Justin was right in that you probably do tie yourself to certain implementations. There might be an argument for having something that really does just to pretend to be that DOM to get around, to let you use multiple, or any sort of MV star library. So we've gone with an MVVM solution where we get the main benefit from the view model, and we specifically use Knockout. The point here is that this view model is a logical representation of the state of your UI. So what I mean by that is, say the view has an input element and you want it to be disabled or enabled. The view model might have input enabled equals true. Knockout deals with the bindings. We trust Knockout to do its job. It will make sure that the view is rendered with that input enabled. If we set it to false, we know that, again, Knockout will do its job and make sure that input is disabled. So in this case, we know that when we interact with the view model or we check the state of the view model, we're effectively interacting with our UI. As I said, we trust Knockout to do its job there. So our architecture overview of this is relatively simple. A services layer, features, and each of those features have their own view model. So we've achieved all of our three things, but the biggest win really comes when we apply all these things together, where we can test a single feature entirely in isolation. So we can get our application load, our specific feature, single feature functionality loaded into the browser. We can inject, say, a mock service at the service registry level. We can interact with our view model and then see the interactions that's resulted in at the service layer. So the full the full feature logic is executed. Or we can put our fake services into the service registry, get it to behave in certain ways, and then check the state of the view model. Has it been updated to reflect what we expect our UI to look like? So our new testing triangle looks like this. We've got unit tests. We've got this nice thick layer of blade functional tests, so testing that full feature in isolation. We've also got a layer of application tests. So we still have that smoke test. So we still do have the backend services running and have some front end, the full application running, but we tend to keep that as small as possible, around 10% of our tests. And it was 8 hours before, so the big win is taking that 8-hour runtime and taking on a server farm of 100 VMs to 30 minutes on a single machine. And not only that, because you're building your feature in isolation, you don't really need to run the full application suite. So when before you check in, you don't necessarily need to run that full application suite of tests. You can just run your feature-based tests, and because it's built in a loosely coupled way, that the interactions aren't going to break the rest of the application. So to answer that question, how do you test ginormous JavaScript applications? We've basically gone back to scratch, thought about how we can build an application with an architecture that is completely testable. So those are components, and the future may well be web components, where we have a services layer for avoiding I/O, and where we have MVVM, so we're avoiding that DOM. There's things like React, which have a virtual DOM to help with this sort of thing as well. So modular web applications of the future, I think. So that's it. Thank you very much. It would be great to find out what you think about this and how you're achieving similar things in the discussion track. Thank you.